Okay, so in the last session we started with Infix to Postfix conversion, and we have seen what do you mean by Infix, what do you mean by Postfix, what do you mean by prefix, and accordingly we started with the conversion of Infix to Postfix. Okay, we started with the implementation. Fine. So we started with the implementation of Infix to Postfix, and we know that it's an application of stack. So we have a stack over here. Then we started with the convert method or the convert function, and we discussed that to this convert function we'll be passing the infix expression in the form of a string, and this function will convert that infix into a postfix, and it will return us the postfix expression in the form of string. So the function is going to accept a string, and here we have specified the string as a pointer to character, and the function would return a string, again pointer to character. Okay. Then we started with the function definition, and the first thing we did is the initialization of the stack, which we have declared into this function, and then we started scanning the infix string. Infix string is into expr, and what the algorithm says that infix string should be scanned from left to right. So if my infix string is a plus b into c, so from left we will start. So first character we are going to read is a, then second character is plus, then the third character is b, then into, that is star, and then the last one is c. So we will read from left to right, and for that we have a simple for loop. For I equals to 0, expr of I not equals to null. So we will be going up to the end of a string I plus plus. So we'll be reading one character at a time. That's why we are writing I plus plus. And then we are taking one character into this variable sc. Now here we'll be declaring a postfix string. So let me declare a string for it. So character star pxpr. So this becomes my postfix expression. pxpr stands for postfix expression. Okay. So this is also a pointer to character. Since we are going to declare it as a string, we need to declare it as a string. That's why we are declaring it a pointer to character. Now, once we declare it as a pointer to character, and now we want to put characters into it. Okay, we are going to create this string. Now, since we are going to initialize the string character by character, so we need to allocate a space to this, because this is simply a pointer. Space has not been allocated, or memory has not been allocated. When you declare array, it has a static memory allocation. So depending upon the size of the array, which we specify into the square bracket, depending upon that number, memory has been allocated to the array. But in case of a pointer, we need to go for something called as a dynamic memory allocation. And that dynamic memory allocation will be doing with the help of a library function called malloc. So malloc is the library function which we will use to allocate a space to our pointer PEXPR. So malloc is a function which will be used to allocate a memory. Now, how much memory we need to allocate? So here we need to specify the size, the number of bytes which we want to allocate to a pointer. So this depends upon the size of EXPR. Means what I mean to say that the size of the postfix string won't be more than the size of your infix string. In fact, it would be less in case if the infix string has left and right parentheses. If the infix string has got parentheses or brackets, then the size of postfix will be less than the infix, or else it would be at the most equal to the size of infix. So whatever is the size of infix, that much memory we can allocate to postfix. So how we would be doing that? We can make use of str_len function, and here I can pass expr. This will return us the length of the infix string, and if I want one more character on a safer side, I can go for that. So +1. Okay, so this much bytes we need for PXPR, and this should be typecasted. The return pointer for malloc, which is by default a void type, this should be typecasted to a type of PXPR. Now PXPR is character star type, so here I would be writing character star for typecasting. Okay, and this returned value, which will be address of the block of this much memory size. So that address we want into PXPR. So PXPR. Okay. So now our statement becomes PXPR equals to char star. This is for typecasting, malloc, a library function, and then the number of bytes we need. So str_len of PXPR, we are going for 1 byte extra, so +1. So that that much number we are specifying to the malloc function. Malloc function will allocate. On successful allocation, it will return the address of that block which has been allocated, and that address will go into PXPR. Okay. If for any reason malloc cannot allocate a memory, in that case it will return a null value. I repeat, in that case it will return a null value, so that null value will be stored into PXPR. So for safe programming here, you can check for the null value. So if PXPR is null, then we cannot proceed because the memory has not been allocated. If PXPR is not null, so we can proceed for the remaining part of the code. Okay, so that is for safe coding. I am leaving that up to you. So now let's start with some simple cases, and then we'll jump to the this operator case. So if your if it is left para, if left para is encountered, then what we need to do? Please answer me into the chat box. If a left para is encountered, then what you need to do? Yes, please. In an algorithm, infix to postfix, if a left para is encountered, then what we need to do? Am I audible? Yes, I need an answer. Please fast. If a left para is encountered, then what we need to do? Push it onto the stack. Push it onto the stack. Yes, we simply need to push it onto the stack. We do not need to do anything extra. Simply push it onto the stack if a left para is encountered. So for that, I would call the push function. The first is the address of our stack. The name of the stack is S, so %S, comma, what I need to send? That left para, and left para is in the character SC. Okay, so here I can write SC. In our main program, this is basically SC. So let me make it C. to have the similarity. And SC is a different character which stores other value. Let it be CC everywhere. Okay. So push ampersand S comma C. We are pushing the left para. If it is a right para, what to do? If a right para is encountered, come on, if a right para is encountered, then what to do? If a right parenthesis is encountered while reading the infix string, then what we need to do? We need to repeatedly, the algorithm says that, repeatedly pop from stack and add to B. Repeatedly pop from stack and add to B until a left para is popped. Do not copy left para in B. B is your postfix string. So repeatedly pop from stack until a left para is popped, and whatever you are popping, you need to add it to your postfix string. But finally, when a left para is popped, do not add left para to your postfix string. Okay, so let's do that. Repeatedly means we can make use of a loop. So let me make use of a while loop. So repeatedly I will pop. So the popped character I am going to read into, say, my character SC. So SC equals to pop, and I need to pass the address of my stack, that is S. So SC equals to pop, and this popped character is not equals to left para. Okay. So if it is not equal to, we are popping from stack, and if it is not equal to whatever we have popped from stack, if that is not equals to left para, so what we'll be doing, we'll be copying that into a postfix string. So I would be simply saying pxpr, and here I need some index, so let me go for the j plus plus equals to sc. Okay, and let me declare j. And j has an initial value of say 0. So what we are doing into this, while sc equals to pop ampersand s, so we are popping from the stack s, we are taking that popped character into sc, and if this sc is not equals to this left para, we'll be copying sc into pxpr. Okay, if sc, the popped character from the stack, is not equals to left para, we'll copy that into our postfix string. That's what we are doing over here. If it equals to left para, the moment we pop left para into sc, so that will not be copied into pxpr, that is your postfix string. Anything else you need to do into this? Anything else do we need to do? No? Done? Okay. Then if it is default case I mean to say it is an operand. So what we need to do if an encountered symbol is an operand? What we need to do if an encountered symbol or the character is an operand? We need to simply copy it to pxpr. We need to simply copy it into the postfix string. Okay. So here I will be writing pxpr of j plus plus equals to the character c. That's all. So default case is pxpr of j plus plus equals to c. Why j plus plus? Whatever is the index value of j at that location into the postfix string, we'll copy this character and then we'll increment the index by 1. Okay, so we are done with the 3 cases: a left para, a right para, and operand. Okay, if it is an operator, this case. If it is an operator, then what to do? Here we have the bigger thing. Here what we need to do? We need to repeatedly pop from the top of stack operator which has similar or higher precedence than the encountered operator and copy that operator into the postfix string. Repeatedly ये काम हमको करते जाना है, and after that we'll be pushing the encountered operator onto the stack. Okay, so repeatedly pop from the top of stack until a condition is met, until a condition is satisfied. What is that condition? That condition is simply what? An operator on the top of stack is having a precedence or priority similar or greater than the precedence of the encountered operator. Okay, so first of all we need to have some mechanism by which we would come to know the precedence of an operator. I repeat, we need to have something by which we would come to know the precedence of an operator. So how we would come to know the precedence of an operator? For that, we'll be having another function. Let me call that function as precedence. Okay. What this function would do? This function would accept an operator and it will return a precedence of that operator. It is as simple as that. I repeat, the function will accept an operator and it will return the precedence of an operator. So now the operator is of what type? Operator is integer or operator is float? No, operator is of character type. So here I write char, say op for operator, and what it is going to return? It is going to return a precedence. Now precedence or the priority can be implemented in the form of integer values. Okay, so the simplest setup would be like this. Higher the integer value, more is the precedence. Generally it is the reverse one. Lower the integer value, more is the precedence. But to have a simple implementation, what we will do, if the precedence is higher, if the priority is higher, so we'll be returning a higher value. So the return value can be simply an integer type value. So the return type becomes integer and then we define the function. So how we'll be defining the function? We have the operator in op variable. We need to check the operator. Depending upon the operator, we'll be returning an integer value. So for example, I make use of switch case. So we would switch between the values of this OP and we have various cases. For example, into single quotes, because we are comparing it with a character, constant character is specified in single quotes. So it can be, say, dollar. My case can be dollar, or my case can be cap. Now what we'll be doing, I think in one of the last sessions, we had a discussion that your slash, that is div operator and star operator, has higher precedence than plus and minus operator. Okay, and in one of the session I said that this dollar or cap, dollar and cap both stand for same thing, that is power 2. So if you want to write x raised to y, you can write x dollar y or x cap y. So x cap y or x dollar y means x raised to y. Okay. Now in one of the sessions I said you that dollar and cap can have a similar priority to div and star, that is division and multiplication. But we can set a priority of this operator higher than the priority of div and star, and that is better. That is better So I can now safely say that dollar or the cap, that is power 2 operator, has the highest priority. So in this case, I would be returning a higher number. So let me write a return, say 3. Okay? And break, which is of no use, but still I write it. The next case is case div or a case star. Okay. In both the cases, I would be returning 2, next lower value. The next case is case plus or case minus. I would be returning, say, 1. And then finally, in the default case, if I am getting any operator which is other than these operators, than the defined operators, then I would return 0. So it means that that operator will have a minimum or the lowest precedence or lowest priority. Okay. And again, coming back to this point, since we are returning from the function, so this break doesn't make any sense. So I can remove this break statement. So now what do we have into this function? We have we are returning 3 if the operator is dollar or cap. Then we are returning 2 if the operator is slash, that is div, or multiplication star. Then we are returning 1 if the operator is plus or minus. If the operator is having any value other than this operators, means any operator apart from these defined operators, then we'll be returning 0. Okay. So this is our precedence function. Now here we'll be making use of that function. So idea is repeatedly pop. So make use of a while loop. So repeatedly pop, and when do we need to pop? Only when the precedence of the operator on the top of stack is greater or similar to the precedence of the encountered operator. Okay? So I write the same thing in the coding part. Please see carefully. Please see carefully. Same thing in the coding part. Precedence of the operator on the top of stack. So how I will get it? I will call the precedence function. Please see carefully. Precedence of the operator on the top of stack. My stack is S and dot. The name of the array is A in square bracket S dot top. Okay. See carefully what I have written. What I am passing to the precedence function, this I am passing to the precedence function. What is that? S dot A in square bracket S dot top. Okay. So it simply means that whatever is on the top of my stack S, that I am taking. I am reading it. Okay. Still we have not popped it. Still we have not popped it. So I am just reading a operator which is on the top of stack by writing S dot A in square bracket S dot top. Okay. This operator will be passed to the function precedence. This operator will be passed to the function precedence, and this function, depending upon the operator, will return us a integer value, and that integer value will be the precedence of the operator or the priority of the operator. What we need to do, we need to compare this precedence, the operator on the top of stack, with the precedence of the encountered operator, with the precedence of the encountered operator. So if the precedence of the operator on the top of stack is greater than or equal to, just a minute, okay, what we were talking, precedence of the operator on the top of stack is greater than or equal to the precedence of the encountered operator. And the encountered operator is in C. So I simply write C. Okay. So while precedence of the operator on the top of stack is greater than or equal to the precedence of the encountered operator, what we need to do? We need to copy that operator PXPR into B. So PXPR of J plus plus equals to, now pop and copy. Okay, pop it. So equals to pop ampersand S. So we'll pop from the stack S, and that will directly take into PXPR. Okay. One more thing. We need to check if the stack is not empty. So if the stack is not empty, then only we can read it. Okay. If the stack is not empty, then only we can read from the stack, or then only we can pop from the stack. So here I need to put that condition. We have the empty function over there. So the function is empty. Okay. So we'll be calling that function here. So is empty. What I am passing %s. Okay, we are passing a pointer. So my stack should not be empty. So is empty will return us true if the stack is empty, and it will return us false if the stack is not empty. Okay. So is empty ampersand s, returning if the stack is not empty, it is returning us false. I need to convert it into true. So I take not. Okay. Now please try to read it very clearly. What does it mean? Not is empty. So if my stack is not empty, and at the same time, double ampersand, and at the same time, precedence of the operator on the top of stack is greater than or equal to the precedence of the encountered operator, then pop that operator from the stack and copy it to the postfix tree. I repeat, if my stack is not empty, so not is empty. Not, इसके लिए हमने not symbol डाल दिया. So if my stack is not empty, and at the same time the precedence of the operator on the top of stack is similar to or greater than the precedence of the encountered operator, then only we'll pop this operator from the stack and copy it to the postfix tree. And that's what we are doing here. Okay. So this loop will take care of that repeated statement, repeatedly pop from stack. Then out of this loop, what we need to do? Push the encountered operator onto the stack. So push ampersand s, comma, C. So we have pushed it. Okay, so we have handled these cases. Now, which all operators we are handling? Plus, minus, div, star, dollar, cap. So all these operators precedence is defined in the precedent function. So yes, we are done with all the four possibilities: operator, left para, right para, and then by default is your operand. Okay. Then we come out of this switch case, and outside this switch case, what we need to do? Whatever is there into the stack, if my stack is not empty, so whatever is there in the stack, till the stack gets empty, I need to pop that and copy it into the postfix tree. Copy it into the postfix tree. So that we need to do. So here I would be saying while, again not empty, %s, while my stack is not empty, pxpr of j plus plus equals to pop ampersand s. Okay. So while our stack is not empty, जब तक हमारी stack empty नहीं होती, तब तक के will keep on popping and popping it to the postfix string. Then finally, once our postfix string is done already, then I would say pxpr of j at the end. A string is a sequence of characters or a flow of characters which is terminated by a special symbol called a null. Now this string pxpr is a string which is prepared or made by us. Now since we are making this string, it is our responsibility that once the string is done, once our string is ready, then at the end of that string we need to add null symbol. So at the end, now our pxpr or the postfix string is ready. So at the end we will say this pxpr of j equals to, in single quotes, I need to put /0 for null. Okay. Now all these things, just a minute please. Yes. So what we are doing that this switch case should be done and the for loop should be completed here, and then this is the end of the for loop, and getting extra. So our pxpr is also ready. Now we can return it. Return pxpr. Let's see again whether the function is done or not. A convert function, few variables, a pointer, a stack, then allocating a memory to our pointer, then scanning from left to right for I equals to 0 to pxpr of I not equals to null I plus plus, then reading a character into C, C equals to pxpr of I, then switching between the value of C, if it is a character, if it is a operator, then do this, and if it is a left para, then do this, if it is a right para, then do this, else it is going to be an operand, so do this, and this is the end of switch case, this is the end of for loop, and do you need to do anything extra into this? No. Then a while loop, copy whatever is there into the stack, into pxpr, then terminate pxpr, then return pxpr. Okay, done. So now inside this main function, let me remove all this. So main function is clean, and here I am going to have few pointers, or to keep it safe, we can have arrays infix of say 50 size, then post of say 50 size, no, I need to have it as a pointer postfix. Let me make this infix also as a pointer. Then ask for the infix string, enter the infix expression, scan it. You can do a getters also. Let us see if it creates a problem with scanf, then we'll make use of getters. %s and a name of a pointer infix. Then I will call the convert function simply. I will pass infix to convert function. It will return as postfix. So let me write here postfix equals to. In fact, why do I need this postfix? I can simply printf and on a new line postfix expression is this one. Okay, so now let's compile this code and let's see what output we get. And for that, I will be going to my command prompt and cd to 2021. Sorry, and here I have my code as session11.c. So our program is into session11.c. I will be making use of GCC compiler. So see the command GCC space the name of the file session11.c. Let's compile it at C. Few errors are there. Semicolon missing on line number 27. Okay, sorry about that. Here it is. Done. Anything else? What else? Then while okay, one parenthesis is left. While sc equals to pop. Yes, here I need one more. Not equals to. Yes, now it is fine. What's another error? Expected expression token. One curly braces is missing. Where it is? Switch is closed here. Ball is closed there. And then this one closed fine, absolutely fine. This is also fine. This is also fine. Okay. Let's compile it again. Still I have an error. All warnings, one error. Semicolon. What happens when you switch from one programming language to another? So this kind of issues happen. So specifically when you switch from Python to C, so generally we forget the semicolons. So warnings, no issues about the warnings, and so code is done. Now you need to understand that when you make use of GCC compiler on Windows machine, and when you compile the code, it creates an executable, and the name of the executable is a.exe in the same folder. So in this folder only, we have a.exe, which is an executable created from this compilation process by GCC. Okay, and every time whenever you whenever you compile your code, it rewrites that executable file a.exe. So what I need to do, I will show you dir. So at the end here you can see a.exe is there, and I need to simply execute this file by writing what? a.exe. So it is asking for the infix expression, enter the infix expression, and I say a plus b into c. Stuck. We aren't getting any output. Whether this infix is properly scanning or not. Sorry. I'm changing a code, so I need to compile my program again. No error, only warnings. Warnings don't have an issue. A plus b into c. Not getting scanned. That's the problem when you deal with pointers. Scanf has a lot of issues. Let me try this. Please hold on. Just a minute. Okay, so we are getting a postfix expression a plus b into c. The equivalent postfix of a plus b into c is a b c star plus. Okay, now you can see here coding is going on perfectly. Convert function is working perfectly. Initially, when we were not getting any output, so here you can see that it was because of pointers. Okay, that scanf function and even the getS function, it was not working as expected, and generally it does vary from platform to platform in C programming language, at least in C programming language for this scanf and getS function. So what I did, I allotted a single byte to the infix. Okay, and then I am making use of this infix for the scanf function. So this has solved our problem. Okay, I allotted a single byte of one character, so size of a character, and this I have allocated to the infix, and then it is working perfectly. So let's try with some bigger one, and let's see whether we get the output or not. Now we solved one bigger example with all those this one with this one, and the equivalent infix is this one, a into b plus c, a into b plus c divide by in parenthesis a minus b into d parenthesis close, then dollar a plus c, dollar a plus c into d. Let's check. Yes, a plus c into d. So again a plus b, a into b plus c, a into b plus c, divide by in bracket a minus b into d, divide by in bracket a minus b into d, dollar a plus c into d, dollar a plus c into d. Now let's give this input to our program and let's see the output. So our program is giving us the output as a b star c a b d star minus a dollar slash plus c d star plus. And what output we got there when we solve this example? This is the output which we have got. A plus AB star CABD, AB star CABD, star minus, yes, star minus, then there we got slash A, and here we are not getting slash A. Can someone answer me? Yes. Now this is interesting. Why little different output over here? यहाँ पर डॉलर और स्लैश का ये जो आउटपुट है ये अलग क्यों आ रहा है हमारा? Why we are having different output over here? In the chat box, please can someone answer me? Why we are getting different output? Yes, come on. When we solve the example, we are getting one output, but there in program we are getting another output. So what's the reason for that? Due to precedence. Okay. What kind of precedence? What kind of precedence? What we did in the example? How did we solve in the example? We solved in the example by making dollar, cap, div and star of same precedence. But when we implemented in the code, what we did? Dollar and cap highest precedence, star and div next highest precedence. So the precedence of slash and star is less than the precedence of dollar and cap. Okay. But when we solve this example, so while solving the example manually, we assume that the precedence of dollar, cap, slash, and star, all four characters are having the same precedence. And I think I have written here also somewhere. Yes. So with this assumption, we solve the example, but we need to change this assumption. And what we will be doing now? That slash and dollar has got the second highest precedence. Second highest. And this I can say third highest. And now from here, I would be removing okay. So with this, you will be resolving the example, and when you resolve the example, then definitely you will get this output, or you should get this output. Okay. So this way, you can give any input to your your infix expression, and you will get the equivalent postfix expression. So this is the code for it, and this program is basically implementation of infix to postfix. So entire coding is done. Instead of executing the program again and again, here also you can make up infinite loop, and there you can have something like asking for the infix string and showing the postfix string, then again continuing for the infix string. Let me do that also. So what I can do, so here I need to execute this loop at least once, so I can make use of a do while loop. So simple implementation, sorry. Okay, let it be. And I will put up this code here. So what I am doing, care y, here I will be doing printf on a new line, the space. Do you want to continue? In bracket, yes or no kind of question. And this will be scanning of character value into a variable c over here, sorry, y, and into this condition I would be writing while while C equals Y or C double equals capital Y. Okay. So here instead of having a exit function call, what we have? We have a do while loop, and inside a do while loop, we are doing all these things, scanning, asking for the Infix expression, and then this is not required. Let's compile this code. Let me make it C. Character C. Okay, all warnings, no error. All warnings can be ignored. And now I execute the exe file, enter the Infix expression A plus B into C, and it gives you an output, but it doesn't wait. Do you want to continue? Again, an issue with scanf. It's a problem. Unnecessary. So yes, Postfix expression for the A plus B into C is ABC into plus, and now I change it. I say A into B plus C. So for A plus A into B plus C, the postfix expression is AB into C plus, and so on. So this way I can keep on continuing. I can keep on giving different examples. Yes. Capital A plus B into, in bracket, A minus C divided by B, bracket close, then divide by A minus C into B. Okay. So for this infix expression, this is the equivalent postfix expression, and likewise you'll get the postfix for the any given infix expression. I don't want to continue this. I say no, and I come out of a code. Now there could be a question: why do we have this additional scanf function over here? So this is to get rid of all issues which we are getting because of pointers and scanf. Pointers and scanf always have a problem. So something like an additional new line gets into the buffer, and because of that extra character into the buffer, the scanf, single scanf will ignore. Okay. So for time being, you just understand that you are going to have two scanf, and this way it is something like solving a problem which we have because of pointers and scanf. So this is your code for the infix to postfix conversion. And now what we will do, we will sorry. Now we can start a discussion session. So I don't want to go beyond this topic today. So today what we will be doing, we are done with infix to postfix conversion, and we are done with the program for infix to postfix conversion. This program I would be providing you. In fact, all the programs are available on my GitHub account. I will be sharing the link of the GitHub account. So from there you will get the code for this. Now we can start the discussion. So whatever problems or whatever issues you have into this code, now you can ask me the question, or if anything is not clear to you, if not understood to you, please ask me, because this program is important. You should understand this program. Important not only from concept point of view, but important from your exam point of view also. It is a part of your lab, it is a part of your theory, it can come in your practical examination, it can come in your theory examination. In theory examination also a program comes. A programs do come for infix to postfix conversion. This program is very important from understanding the concept, from understanding the algorithm, and from implementation point of view. So if you have any query, please post your query into your chat box, or you can unmute your mic and you can ask me a query. Please, sir, tell that scanf problem at last. Better not to discuss the scanf or the pointer issue right now, because as I said you, there is some problem with pointers and scanf. When we make use of pointers and scanf, there are issues. So at times the scanf function is you would come to know it has been ignored, and that's what we were facing initially also. So let's not discuss on that. Let's restrict our discussion on the program, the main part of the program, that is the logic, the concept, that how that has been done. Because scanf and pointer, it's more of C programming issue, not this program issue. What is malloc? Malloc stands for memory allocation. Okay, MALLOC. Malloc stands for memory allocation. Now, earlier also I said you that when we make use of arrays, arrays uses something called a static memory allocation. Okay, what I mean to say that when I write something like this, character A in square bracket max. Okay, so what we are doing here, we are declaring an array A of character type of max size, and the value of max is defined here, 50. Now this is important. If you do not define a value in this square brackets while declaring the array, your array declaration will not be done. Why it is required? Because array makes use of something called as static memory allocation. Now what do you mean by static memory allocation? Static means fixed. Static means fixed. So at the time of compilation itself, the information is there that the size of the array is 50, and if one character is taking 1 byte, so this array will take 50 bytes, because this array is an array of character type of 50 elements. Okay, so this array A will take 50 bytes. So a 50 bytes block is allocated during the compilation of the code itself. So when this program is compiled, at that time itself, a block of 50 bytes is allocated, and that block is having a name A. That block is having a name as A, depending upon the name of the array. Okay. Now, when we make use of pointers, so basically in pointers, we can go for dynamic memory allocation. What is the disadvantage of the static memory allocation? That the static memory allocation is fixed, it is static, it is done at the time of compilation. So during execution, when your program executes, so during execution, you cannot change this fixed memory allocation. You cannot resize this array during the execution of the program. So if the array is defined for 50 elements, it will remain there in the memory for 50 elements. Okay. If you make use of 45 elements, then 5 elements space will be wasted. And if you want to make use of this array for 51 elements, you cannot, because the array is defined only for 50 elements. So this is the disadvantage of array or static memory allocation. What is the disadvantage? You cannot resize it during the program execution, or you can say memory wastage. What happens in a pointer? We can allocate a memory during the execution of the program itself, and that is done with the help of library function malloc. So malloc is a library function which is used to allocate the memory during the execution of the program. So जो memory allocation है, that is not done during the compilation. Compilation is one step, the first step. Execution is the next step. Okay. Compilation of the C program starts from the first line. Execution of the C program always starts from the main function. That you should remember. So malloc is the function which will allocate a memory during the execution of a program. Okay. Now during the execution of the program, depending upon our requirement, we can allocate a memory. And then the allocated memory address, the starting address, can be assigned to a pointer, and using that pointer, we can access that memory block. Okay. So what we are doing over here, when we make use of a malloc function, we need to pass some information. What information? That how much memory you want to allocate it. How much memory you want to allocate. Okay. For example, I will be specifying that information in the number of bytes, that I want this many bytes to be allocated. Okay. And here what we are doing, we are taking the size of EXPR. We are finding the length of EXPR using strlen. So this strlen, the strlen function will give you the length of the EXPR. EXPR is our infix string, infix expression. Whatever is the length, A plus B into C. So A plus B into C. The length is 5. Okay. So I have 5 bytes, 5 characters. One character takes 1 byte. So it becomes 5 bytes. So I have 5 bytes. So 5 bytes plus 1. Okay. 1 additional. So this many bytes we are asking to malloc function to allocate. So 6 bytes will be allocated for this specific example, A plus B into C. 6 bytes will be allocated to a pointer PXPR. So that is the use of the malloc function. Okay. Now we are doing this during the execution of a program. So this is called dynamic memory allocation. It is called dynamic memory allocation. And why do we have this character star or char star before malloc? This is nothing but called typecasting. What we call it? Typecasting. Malloc function is returning you an address, and by default it is void type. Address means pointer. So by default it is a pointer to void. I repeat, by default it is a pointer to void. So I need to convert it into, or typecast it into, a pointer type which my PXPR is. Now this PXPR जिसके अंदर हम एड्रेस ले रहे, this PXPR is of which type? It is of type char star, pointer to character. PXPR is char star, pointer to character. That's why in the typecasting we are writing char star. Are you getting it? And likewise in the main function also, when we are allocating a space, Okay. Here infix is of which type? Again, char star, pointer to character. That's why I'm writing here char star. And size of single character. I am specifying the data type char, so it will take the size of that char. So I am going to allocate only 1 byte. Okay, that is just to get rid of the problem which occurred because of pointer and scanf. Hope I have cleared the malloc function requirement, or why do we have the malloc function. Any other question, please? Yes, any other question about the logic? The main part is in your convert function. The convert function is doing everything. Convert function में we are using a stack. We are initializing the stack, and then we are allocating a space, a memory to our pointer pxpr, and then we are scanning the infix string pxpr from left to right. Sorry, from left to right. From left to right, we are scanning the infix string, and if the scan symbol, the scan character we are taking in C, if the scan symbol is an operator, if the scan symbol is any of these operators, then we are doing this logic. The logic is the step of the algorithm. What is that step? Repeatedly pop from the top of stack an operator which has precedence similar or higher than the encountered operator, and copy it to your postfix string B. Okay, so that's what we are doing over here. While my stack is not empty, and at the same time the precedence of the operator on the top of stack, the precedence of the operator on the top of stack is greater than or equal to, similar or higher, means greater than or equal to the precedence of the encountered operator. Okay, if these conditions are satisfied, then we need to pop that operator and copy it to our postfix string pxpr. Okay, and then when this thing is repeatedly done, this is inside our while loop. When this thing is repeatedly done, whenever the condition is false, means either my stack is empty or the precedence of the operator on the top of stack is not greater than or equal to the precedence of the encountered operator. So in that case, we'll come out of a while loop and then push the encountered operator onto the stack. Okay? Then next case is left para. In left para, we need to simply push it onto the stack. Then the next case is right para. For right para, repeatedly pop from stack and copy to the postfix string until a left para is encountered. Do not copy the left para onto the postfix string. So that's why inside this while only we are popping. We are popping inside the while. So pop ~s, and that popped character is into SC, or the popped operator is into SC. Then we are comparing this with left parenthesis. If it is not equals to left para, then copy that operator into pxpr. Okay. When it is left para, then do not copy, because the condition is false, so it will not come inside the while loop. Then the last case is the default case. By default, if it is not an operator, not a left para, not a right para, then by default it is an operand. So in that case, simply copy it to the postfix string pxpr. This is the end of a switch case. This is the end of a for loop. And then after your for loop, when your string is exhausted, so whatever is there inside your stack, copy that, pop that, and copy it into the postfix string. Okay. So while my stack is not empty, pop from the stack and copy it to pxpr. Once this is completely done, then your pxpr is ready. Once your pxpr is ready, since your pxpr is a string which is created by us, it is our responsibility to terminate that string. string termination is done using a null symbol. So that's why we are writing pxpr of j equals to /0, and then we are finally returning the pxpr, that is the postfix string. Okay. So this is the complete code or the complete program for your infix to postfix conversion. Still any query? Any question, any query? Please feel free to ask. You can put your question into the chat box, or you can unmute your mic and ask a question. In exam, will creating a stack without structure be valid? If I am assessing that exam, then it's not valid. If I am accessing that exam, then I won't be making it valid, because that's poor programming. Absolutely poor programming, according to me. And what we are learning, we are not only learning data structure, we are also learning how to program it better. What is the better way to program, to code your problem? Okay, so whenever you have a problem and whenever you are solving the problem, you should always go with a better approach. Fine. Absolutely, you can make your stack without a structure, but that is not recommended. Not at all recommended. Any other question? Yes. Yes, please come up. You can unmute your mic. You can ask a question. If there are no more questions, then I can assume that the entire program is understood to you. And once we are done with stack and queue, then we shall be having a small test for the first module and the second module before your UT1. And for the programming part, for the lab part, uh, along with this program, we are completing the experiments also. So your first experiment is to understand how to go for a modular program. So the modular program which we discussed in the beginning, that is your first experiment. I will give you the entire list of experiments. Then your second experiment is implementation of stack using array. So the program which we have discussed for implementation of stack using array, the same program you have. And then the third experiment is this one, Infix to Postfix conversion. This is your third experiment or the third program. Okay. So today we are done with the third program also. So what we are doing, we are completing your theory part also, and we are simultaneously completing your practical or the lab part also. Okay. And that's why I'm combining the sessions. Though this is a lab session, but I'm combining your lab session with the theory session, and we are ensuring that whatever we are covering in the theory part, the same program we are going to take into the lab part. Okay, so it's like both sides we are completing at the same time. We are completing your theory part also, we are completing your lab part also, and that's why we are in a position to give more time for the explanation. Otherwise, we are short of time. We are running short of time. But since we are combining the things and we are taking the same programs into the lab part also, that's why we can give more time for the discussion part. We can give more time for the explanation part. So this is the third experiment of your lab, third program. So this way we are done with the first three programs. Yes, any question? If no more question, then I can stop the recording part, and then I can send you the attendance. So recording is getting stored into Sheikh Afsar Ahmed Google Drive. Sheikh Afsar Ahmed, please make me editor of this video so that I can download a video and I can make it available for you people on the YouTube.